Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving letter tile possibilities. So the problem states that we have n tiles and each tile has one letter printed on it, and we want to return the number of possible non-empty sequences of letters that we can make using the letters printed on those tiles. So if we look at this example, we can print 8 non-empty sequences, which these are the 8 possible sequences that we can print: A, B, AA, AB, BA, AAB, ABA, and BAA. And this one has 188, which we don't have enough time to lay out all the sequences. And for this example, obviously it only has one output because the only non-empty sequence that we can make is V. So the output is 1. So now that we have seen some examples, let's get to how we can solve this problem. I won't spend too much time explaining the brute force because it's just not optimal, but one of the ways that we can solve this problem is we can start with an empty string, and at each step we can add one letter from each letters of the string, and that will also be the case if we have duplicate letters. So if it was ABA, we will also add ABA rather than just AB. However, in the more optimal solution, you will see that it's actually not necessary to use all the letters if they are duplicates. So that's why there's a more efficient way to solve this problem. But the time complexity of this method would be n times n factorial, because there will be n characters to go through, and at each character we will have n factorial options. So it will be n times n factorial. But as I said before, there's a more efficient way to solve this problem, so let's go over that way right now. So I think I'll explain this approach with an example, and I'll first go over what the strings mean, and then I'll go over what this dictionary means. So we want to approach this problem as if we are starting with an empty string, and at the start we can choose to add an A or B, but we don't need to add A again even though we have two A's. We just need to add the unique characters that we have the options to add. So we can add A or B. And if we choose to add B, then our only option is to add A afterwards, and then we can add A afterwards. As you can see, these are all possible sequences. And if we go this route, if we choose to add A, then we can choose to add A again, or we can choose to add B. And if we choose to add B, then we can add A afterwards. And if we choose to add A first, then we can add B afterwards. So in total, there will be 8 possible sequences for this example. However, in the coding solution, we will approach it more of as a hash map, but the hash map does not represent the current string that we have. It more so just represents the options that we can add to the current string, which is the empty string in the beginning, and the hash maps later on in the calls would be the available options that we can add to whatever current strings that we have. And as you can see, the number next to the hash map is the number of possible sequences that you can make. So if we see here, we will add what we can make on this hash map and this hash map, and we will add one number to each route. So it will be 8 over here. And for right here, if all we are given is 1A and 1B, it doesn't matter the order, then we can make 4 sequences. So 1 from this hash map, 1 from this hash map, and 2 of the routes. And as you can see here, if we're given 2 A's, then we can make 2 sequences, which would be 2 A's and 1 A. And if we only have 1 A, then the possible sequence is just an A. So that is what this chart is explaining. Time complexity of this approach would be O of 2 to the nth power, where n is the number of strings in the input string. Because at each character in the input string, we have 2 decisions to make. We can choose to use the character in the sequence or to not use it, and that will stack up to 2 to the nth power time. And the space complexity would be O of n because of the recursive stack that we can possibly make. So now let's get to the coding part. So first, we will set up our helper function, and we'll just call it find. And count would be the dictionary, or the counter for the number of characters we have. We'll set total to 0 in the beginning, and then we will loop through the count dictionary. So if the number of instances of the character is 0, then we just continue. And now we increment total by 1 if there is an instance of it, but we delete that instance. And now we add the recursive call to the total. And after the recursive call, we need to add back that letter or that character. So count of C plus 1. And in the end, we will return the total. Yeah. So in our main function, all we really need to do is set up the counter, the initial counter. So count equals counter of tiles. And that is the input parameter that we are given. And then we just return self.find and with count as the parameter. Okay, let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any questions or comments, feel free to leave it down in the comment section, and I hope to see you all again soon.